For number 5? Yeah. We're going to be going over that.
There's 2.
Yeah, we're going to be going over that. Yeah, the main one makes sense, yeah. Yeah, we don't have to worry about max. Just min. Yeah. But we're also going to talk about it today because we're going to be doing image stuff. So, I don't know. So, we'll see. Also, just logistics. Do we know who's going to go get stuff for tomorrow? Marshall mentioned. He's got the. So, anyways, we'll talk about that later. All right. I think we are now at 12:30. Awesome. Okay. Let's do it. Welcome everybody to yet another wonderful session of Intro to Programming in Python. Today we're going to be going over something called nested for loops. Okay. So we've been using for loops a lot, right? Using for loops to go through something, right? Go through one thing and go through each one of those items. Today we're going to be going through for loops and nested for loops. So using a for loop inside of another for loop. Okay. And we're just going to look to see how that works, how that looks like, and if we have any questions, we can of course stop, and then I'll answer any questions that we have. And we're also going to be going over the concept of 2D lists, okay, 2-dimensional lists, which is just a fancy way of saying a list of lists. That's it. You know how we had lists, and those lists could have numbers, they could have strings, they could have like ints or floats, things like that. Well, a list can also hold another list inside. And we're going to see how that looks like. So a couple of announcements. PA4 is due Sunday night, so make sure to be working on your PA4. I also mentioned how PA3 was due 2 days ago, but if you're using your slip days, then today's the last day to be able to submit it to use up 2 slip days. And then PA5 will be released tomorrow. Okay, PA5 will be released tomorrow. I uploaded grades for labs and PAs up until now, right? Except for lab 5, because lab 5, the grades due for that one at the end of the week, along with lab 6. And if you need help to find the feedback on your PAs, you basically just go to the actual PA where you submitted, and there you should see some feedback in terms of like what grade you got, like if you lost any points, why you lost any points. We told our graders also to make sure to like give y'all comments on certain things like, oh, this is what you would have needed. This is the way that you could have, like maybe you're really, really close and you just needed one thing, and they can show you that through the comments. And of course, always, we have tutor hours, office hours available for all of you. Okay. And yeah, just like I said, midterm scores, they should be out tomorrow afternoon. And then another thing. So it's in the syllabus already, but we have a way to like quote unquote update your midterm scores. Okay, so let's assume in your midterm score you got a 50%, right? Just let's assume you got a 50%. It's not the end of the world, because we have a system where on your final exam, whatever you get on your final exam, if it's greater than your midterm score, we will update your midterm score to be the average between your midterm score and your final exam. So let's say in the midterm you got 50%. Not super great, but it's not the end of the world. And let's say that in the final exam you get 100%, right? So in between 50 and 100 is 75%, right? That's the average. So if you were to have gotten 100% of the final, but 50% of the midterm score, at your total grade, at the end of the grade, your final score is still 100%, but we will update your midterm score to be that 75%, right, in that scenario. So we'll just get whatever is the average between these two scores and update your midterm score. If your final exam is greater than your midterm score. We would not be doing that if your final exam is lower than your midterm score. Otherwise, that would just lower your midterm grade, and that's not what we want. Okay? Any questions on that? Any questions on any of this? It's nice, huh? All right. So, yesterday, you had the midterm, and you had something called the rainfall problem, right? So in the rainfall problem, you have a list, right, of numbers, and those numbers are basically amounts of rainfall, and you're trying to get the average amount of rainfall depending on the amount of days that you have. Okay, so let's just go over the solution to this rainfall problem, so y'all can see exactly how to answer this question. Okay, so I'm gonna move on over here. Here's the rainfall problem. Right? So again, this is writing a function called rainfall that finds the average of all non-negative rainfall values in a given list of data. Please note that non-negative includes any value greater than or equal to 0. So if your number has a 0, then we count that too. Okay. And so yeah, so basically, here's our description. We need a function called rainfall, and it needs a parameter called rain amounts, which ends up being a list of integers that shows the amount of rainfall on a given day. So let's do that really quick. So we need a function, right? I'll call it rainfall, because that's what it's asking for. And we only need one parameter, rain amounts. Right? So now we have our function. And just so I could run the code, I'm just going to put hello world right now. That's not what it's going to do later on, but that's just so I have something, right? I can run it. Okay, great. It's working. Can I call it? Let me call it really fast. Rainfall amounts, I'm just going to say 1, 2, 0, -1, and 2. Something like that. Let me run that. It runs hello world. That's what we assumed, right? Because that's all the function is doing right now. Printing hello world. Now, we have to return a value if there is at least one non-negative value. Sorry, if there is at least one non-negative value, yeah, then we return a float, right? We're going to return just one number that represents the average of amount of rainfall on all the days with a non-negative reading. So what does that mean? If I had 1, 2, 0, -1, and 2, what should we be doing?
Returning the float, because it's at least one non-negative.
There's at least one non-negative number, so we will be returning a float. So what will that float be? Just before we do it programmatically, assuming this list, what should we be returning?
The average amount of rainfall.
All right. Yes, the average amount of rainfall. Can someone tell me what the average amount of rainfall is with this amount right now? Feel free to think out loud. So what's the first step we have to do?
Add all the values on the list.
Add up all the values on the list, right? We have 1. 1 plus 2 is?
3.
Plus 0?
3.
Do we add this 0, yes or no?
Yeah.
Yeah.
Yes, okay. So it is still 3. Do we add this one?
Yes.
No, we do not add this one because it's a negative number. Any negative number, we just skip. Okay?
5.
3 plus 2 is 5. And then we do 5 divided by 1, 2, 3, 4. We only consider the days that have non-negative numbers. If it's a -1 right here, we don't add it up to our total, and we don't consider it in the amount of days. Okay? So it's 5 divided by 1, 2, 3, 4. 5 divided by 4 is some number. 1.25? Something like that? Yeah, 1.25. So that's what we're supposed to be getting. 1.25. But we also already just did the problem in our heads. We have to, one thing we have to do is go through the whole list. How do we go through a list?
For
A for loop, okay. So now we have that, for. We have to go through a list, right? So we can do for rain in rain amounts. Right now, let's just print the rain. Now we can remove this hello world. Let's just print the rain, see what happens. When we print the rain, all it's going to do is going to print out all the values in the list. Great. That's all we need so far. Now, how can I make sure that I'm adding up all my numbers? How can I do that? How can I add up 1 and 2 and 0 and 2? Yes?
Create a variable in your function.
Create a variable in your function, okay. What are we going to call that variable? Anything.
Total rain,
Total rain. Great variable name. And we're going to set that equal to
0.
0. Why 0?
Because you don't have any rain yet.
You don't have any rain yet, okay? Even if you start adding zeros, at the end of the day, you're still at 0 rain. That's good logic, right? So now, what we can do is this. Instead of just printing out the rain, let's just add up all the rain. And the way we do that is we get our total rain, and we add up all of the rain. We just add it all up. Even the negative ones right now. That's not what we want at the end, but let's just start something off. And let me print out our total rain. Why did I put my print outside of the for loop?
Because then it's going to be printing every time the loop iterates.
Yes, otherwise if it's inside, it's just going to keep on printing and printing and printing and printing. Right? That's not what we want. So let's just run that. And so with this, now we have 4. Does this work? There's 1, 2, 3. 3 plus 0 is nothing. 3 minus 1 is 2. 2 plus 2 is 4. Great. Now we're adding everything up. But now we don't want to add up any negative numbers. Right? We for sure don't want to add up any negative numbers. So how do we make sure that we don't add up a negative number?
If statement.
An if statement? That sounds great. Where should I put that?
On where the for loop is on the bottom, like yeah, well underneath.
Underneath this one like this?
Yeah.
Okay, great. There's going to be an if statement. What am I checking?
If rain is greater or equal to 0.
If rain is greater than or equal to 0, then what's going to happen? What should we do if rain is greater than or equal to 0?
Add the rain value to total rain.
Add the rain value to your total rain. Does everyone understand why that is right now? Now if you remove this. Does everyone understand why that is? We're adding up anything into our total rain as long as it's greater than or equal to 0. So anything that's a negative number should not be printed. So when we did our math, 2 plus 1 plus 1 plus 2 plus 0 plus 2, we ignore the negative 1. We should be getting 5. And that's what we get here now. When we print it out, it's 5. So it's working so far. Great. But we don't want to return just the total rain. What we want to return is the average amount of rain across all those days. To get the average, you need your total, which we have now. We have the total amount of rain. But you also have to divide by the number of days that we're considering. Okay? We need to consider a certain amount of days. So, how do we consider only those days that we counted? How could we do that? Yes?
Make like another variable, like below line 2.
Make another variable before or after?
Below.
Below? Great. And what do we want to call this variable?
Maybe like counter.
Counter? Counter sounds like a good name. And what are we going to make that counter equal to?
0.
0. Why 0?
We haven't counted like any numbers greater than 0 yet.
You haven't counted any numbers greater than 0 yet. So we're starting off at 0. Okay? Makes total sense to me. Now that we have this counter, what do we do?
Below line 6,
Right
we
here?
would write like counter plus equals 1.
Counter plus equals 1. Does everyone understand why that is? We're adding up to our counter by 1 every time we find a day that is a non-negative number. Okay? If it's 0 or greater. This counter that we have right here, we have it because this is the number of days that we have total. Right? And we're only incrementing by 1 because we're adding up another day. It's another day we're considering. Okay? Another good name for this could have been like total days, right? Because if you have your total days, it makes it a little bit more descriptive, right? In terms of what you're counting. A counter could have been anything. We could have been counting up all the rain, right? Nothing wrong with using the name counter, but just for like simplicity in terms of like reading the code, let's call it total days, right? This is the total amount of days that we're considering for our average. Does that make sense so far? Right? And then what should we be doing? We have to calculate the average, right? How do we calculate averages?
You divide by how many there are in the list, like positive numbers in the list.
Right? So how are we going to calculate that? So we know how many days, right? We know how many positive number of days we have. What number is that going to be? In terms of like the variable name.
Total rain.
So total rain is all of the rain that's added up?
Oh yeah, sorry. Total.
That's good. So total days is the amount of days that we have, that we're considering. So we need to divide the total amount of rain that we have, all of it, and divide it by the total amount of days that we're considering. How many days are we even adding up in here? It's with total days, and we do it like that, right? And we want to return that average, right? That's what we want to do. We want to return that average. So how do we do that? We do return total rain divided by total days. So we should be getting 1.25, right? No? Why not?
After it runs the first time, if the number is after one input, it'll immediately return the value.
It's going to immediately return the value. The way that we have it written out right now, this return that's inside of your for loop, as soon as we hit return, what happens when we hit return?
It'll go out the loop.
You leave the loop and you leave the function. You leave the entire thing, right? So in theory, what we should have been getting is 1.25. Let's see what happens when we run this. Okay, we get nothing. Okay, we have to print whatever we're returning. Let's just print that out. We should be getting 1.25, but right now we're getting 1. Why are we getting 1? We're getting 1 because of this. Look at Python tutor. Execute. So we have our function and we have our rainfall, which is 1, 2, 0, negative 1, and 2. That's our list. We have our total rain and our total days. We're doing for rain and rain amount. So anytime we see rain, rain is a new amount. In this case, rain is going to first be 1 because it's the first thing in our list. Is rain greater than or equal to 0? It is. 1 is greater than or equal to 0. So we go inside the if statement. Now we're going to update total rain and total days. Total rain, we're going to add 1 to it because it's what rain is. We're going to add days to it because now we're considering this day for our average. And as soon as we hit return, we leave. We leave the whole thing. We never got to finish our for loop. Because when you have a return inside the for loop, it's going to immediately leave. Immediately. Not just the for loop, but the entire function. Even if you had stuff outside the for loop. Look, I had this total rain, print total rain outside the for loop, inside the function, and that did not get printed. Because we never reached that, because as soon as you hit return, you immediately leave. Okay? So that's what that means. Okay? So do people understand why this return shouldn't be inside here? Where should I put this return then?
Outside the for loop.
Outside the for loop, like that. And since we're hitting return, we probably don't need this print anymore. Right? So now, we should be getting 1.25. Let's run that. Hey, 1.25. That's exactly what we needed. What if instead of negative 1 here, we had another 1? So now that's 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5. 6 divided by 5 is like 1.2. Run that. Hey, it's working. Great. We're done? No. Why aren't we done?
Because you still need to test if all values are negative.
Ooh. Does this one we have all negative values? All negative 1. Let's run that, see what happens. Oh no! Division by 0. We can never divide by 0, just in math, period. And that's what we were trying to do here. Our total rain is 0, and our total days is 0. If we're trying to divide by 0, that's not good. Okay? We don't want to do that. So what can we do to check to see if our total days is 0?
Else if.
Another else if, like this. Else if, what are we checking for?
Rain is less than 0.
Rain is less than 0.
Yeah.
Okay. What are we doing when we check if rain is less than 0?
Return a string.
We want to return a string. Right? What do we want to return?
No positive rainfall.
No positive rainfall values. This one, right?
Or it's just an else statement.
Instead of else if, what are we doing?
Maybe an else. There's an else.
An else. Let's try that. See what happens.
And,
Let's run that.
I don't know, just else, like just an else statement.
An else statement?
Yeah.
Oh, like this? Like that?
Yeah.
Okay. So go on here. That's printing that. Let's try this again with our regular values that we had before. Let's run that. It broke stuff. Why is that? So when you have an else state, oh, you go ahead.
Because there's no other conditional statement stopping it from running the else statement.
There's no other conditional statement stopping it from running this else statement. So you're like, there's no other if, right? Says there's no if with this else. Python is saying, just do something if you don't find something else. Maybe. What if we do this? Oh wait, no. Yeah, we already checked for that. So what Caesar's saying is that because there's no if statement, we're always going to go into this else. Else is not comparing against some other if statement. So we're always going to go into this return. So we only want to print this out, or like return this, if something were to happen. When do we print out no positive rainfall values? It's only if something were to have happened. If something were to have happened. So what should I do?
If total days equals 0.
If, so we have to replace this with an if. Total days is equal to 0. Right? Do we understand what's happening here now? When we're saying this, we're saying we're going to read the whole for loop, right? The whole entire thing. If by the end of the whole for loop we still have not found a positive rainfall value, no 0, 1, 2, any positive number, that means our total days never got updated. We never added 1. So we're still at 0, but we cannot divide by 0. So if our total days is 0, then that's when we return no positive rainfall values. Okay? Does that make sense? As to why we want to do that? Any questions on why we do this? Anyone a little confused by this at all? Yes, no, yes, no. Let's run this. So we get our 1.25, which is what we were looking for, right? Now let's print out rainfall with all negative values. Run that. Now we have no positive rainfall values, right? Because we call this twice. Let me just call it just one now. No positive rainfall values. We can also print rainfall 0, 0, 0, 0, 0, right? They're all positive values, but they're all 0. So what should this value be? What's the average rainfall for all these days? 0. Huh? 0. Great. So this is the answer to the rainfall problem. This is the whole answer. Any questions on how we got to this point? No? Yes, no? No? Well, if any of you do have questions on this, please, please, please come to our office hours. Any of the office hours, tutors, TAs, instructors, anyone. Even if it's not me, right, you can go to the other instructor too, on show. I have no hard feelings. It's totally fine. But yes, this is the answer to the ring film problem. Okay? This is how we got to that point. Okay, great. Now, big ideas for today. New material. I think this is like the last or second to last big thing we're learning in CSE 8A. Okay? Like the last big concepts that we have to learn. Right? Or last or second to last. Big concept that we're learning. Nested for loops and 2D lists. Okay? So, what exactly is a nested for loop? Well, I'm going to show you all right now. A nested for loop is literally just a for loop inside of another for loop. Okay? And what we want to do is keep track of our our 4 variables, right? Like for x in something, for y in something, right? So let's just do for I in some set of numbers, a range, right? Let's go up to 5. Okay. So what value should I be right now? What values?
0.
0. What other values?
1,
0, 1.
2, 3, and 4.
0, 1, 2, 3, and 4. Right? Let's just check that. Boom. 0, 1, 2, 3, 4. Fantastic. That's a for loop. Great. Now, what happens if we were to do this? For j in range of 5. Inside of this for loop. Remember, when we go into a for loop, what is the thing that's happening? For whatever. As soon as we go inside, we're going to go in here and loop and keep on doing this until we're done. Non-stop until we're done. Or if we hit break or return, right? It's the only time we're going to leave that for loop. But if you have another for loop in here, for all this other stuff, you go in here, right, into your for loop. You're going to have to for loop inside this until this is done. So that means you could still be like at I is 1 here, or 0, whatever. Now your j inside, is going to go from 0 to 4 every single time I is some other number. Let's just see what that looks like. So let's just print j. Okay? And let's make it like this. Let's say I is equal to stir of I, right? And then j is equal to stir of j. Do people see what I'm doing right now? Just printing out I is equal to I and j is equal to j, just so we can see what those numbers look like. Okay? Let's run that. We see I is 0, then j is 0, j is 1, j is 2, j is 3, j is 4. Then I is 1. Then j is 0, j is 1, j is 2, j is 3, j is 4. Then I is 2. Then j is 0, j is 1, j is 2, j is 3, j is 4. Okay? So every single time we hit this for loop, even though it's inside of another for loop, it needs to loop through all its values before continuing on. Okay? So let's just, instead of doing it like that, print I, like that, what we can do is this. We can say I is equal to stir I, right? And then we're going to just print out like this. So now we're going to print out both values. Instead of printing I, then all the j's, I want to print out I is equal to something and j is equal to something all on the same line. Okay? What this is going to show us is this. When I is 0, right, when we're starting off our for loop, our very first for loop, right? Kind of like that. We're starting off our for loop. I is 0. Great. Then we go into another for loop, and we say j is 0. Great. J is 0 now. I is both 0. I is 0, j is 0. That's what we print out. But then we have to loop, because we finished like the end of this nested for loop, and we loop back up. When we loop back up, I does not get updated. I is still 0, but j does get updated. J is now 1. Then j is 2. Then j is 3. Then j is 4. Right? Once we hit j is 4, we stop that for loop, right? Because the range of 5 is 0, 1, 2, 3, 4. No more numbers after 4. So we finish our inner for loop, this one. And then we loop back all the way up to the first for loop that we had of I. I used to be 0, and now we're updating I to be 1. Because that's the next thing in that range. That range is 5, and I was first 0. When I is finished being 0, I becomes 1. Okay? When I is 1, we hit this for loop again for j, and we have to do that j for loop all the way again until we're done. Does that make sense? Sort of? Maybe this will help in terms of visualization. Print star 30. Okay? It's just like a bunch of strings, okay? Or like a bunch of stars, just to separate our stuff. Let's run that. Here's what it looks like now. So I is 0, and j is 0, 1, 2, 3, 4. Then I is 1, then j is 0, 1, 2, 3, 4. Then I is 2, then j is 0, 1, 2, 3, 4. Does this make sense? Where we're looping, we have one big loop of I, and I is going to still loop all the way around. And now we have an inner loop of j, and the inner loop of j will do it for every iteration of I. Every single time we hit the for loop, we go inside j. Does that make sense? And then, once we're done reading that j, still within the I for loop, we print out these stars. Okay? So we still hit that, and we can say, I don't know, something like finished an iteration of the I loop. Right? Let me just print the stars again. Yeah. So now we see I is 0, then j is 0, 1, 2, 3, 4, right? And we print all those out. Then, still within the I, we print out the stars, we print out that we finished an iteration of the I loop, and we print out the stars again. Then we loop all the way back up. Then I goes from 0 to 1. Then we hit this for loop again, and we start all I is equal to 1, and j is equal to 0, 1, 2, 3, 4. Does this make sense in terms of what this nested loop is doing? Anyone confused by this at all? It's important that you all get your questions in for these nested for loops. Because these nested for loops are going to be very important going forward. For PA5 and PA6. And again, this is going to be like one of the last big things we learn about. Okay? Any questions on nested for loops for now? Or are people kind of sort of getting it so far? Any questions? Yes?
So like the last two print statements, those were for the I, right?
Yeah, these are for these are still within the I for loop, right? So like when I is 0, we do all of this for loop stuff. And while I is 0, we print out this, and we print out this, and we print out this. Then we loop back up. Then I is 1. When I is 1, we do the for loop for j, all of it. Then we print out the stars, we print out finish an iteration of the I loop, and we print out the stars again. Then we loop back up. If you want to print something outside of the I loop, you can print out, hello, Angel. How many times will hello Angel be printed in the whole program?
Just one.
Just once. Because it's not inside the for loop. What if this was in here? how many times will it be printed? Bless you.
5 times.
5 times. Do we know why it's 5 times? Why?
Because there are 5 objects in the range 5.
Right? Range 5 is 0, 1, 2, 3, and 4. So we're going to go through this big for loop 5 times. So we're going to print out hello angel 5 times when it's inside the for loop. How many times will it be printed if we do this? Hello angel.
25.
25 times? Why would it be 25 times?
It prints 5 times for like each 5 times in the I for loop.
So it prints out 5 times for the I for loop. How do we get to 25 then?
Or like inside the J for loop, it'll print 5 times.
Yeah?
And the J for loop gets repeated 5 times.
Yes, that's precisely correct. So inside the J for loop, we know the J for loop loops 5 times, right? We know that for sure. But how many times are we going to read this J for loop? Another 5 times. So that's 5 times 5, which is 25. We print out hello angel 25 times when we do it like this. Looks like that. We say I is 0, J is 0, hello angel. I is 0, J is 1, hello angel. I is 0, J is 2, hello angel. Does that make sense? Yeah? Cool. Thank you for the question. Any other questions about nested for loop so far? No? Maybe some? Again, this is a very important concept. And if you're not sure with any questions, we can come back to this later. Okay? All right, so that's a nested for loop. Right? This is basically what we do right now. Now, let's try this out. We have a for loop, range of for I in range of 2, and it prints out a string called let it be. Then we have a for loop with J in range of 3, and it prints out hey Jude. Then we print out imagine, and then finally we print out the Beatles. Okay. How many times will the following phrases be printed? Like how many times are we going to print out this string, then this string, then that string, and then that string? How many times each? Like for example, what we mean by that is for option A, we would be saying that let it be is being printed once, hey Jude is being printed 3 times, imagine is being printed once, and the Beatles is being printed once. Not to say that that's the answer, but this is what we mean by how many times will the following phrases be printed. Okay? So, how many times will each one of these be printed?
C.
C.
C. Why C?
Because for letter B first is for I in range 2, so it's gonna print 0, 1, and 2, 0 and 1. Which is
2 times.
Then hey Jude is within the nested for loop, so it's gonna be 2 times 6, 2 times 3, which is 6.
2 times 3 is 6.
And imagine is within the first for loop, so that's just gonna be 2 as well.
2 times. Okay.
And then the print, the Beatles is outside the for loop, which is just 1.
Great. That's the right answer. It's C. Okay. Thank you for the explanation too. That's exactly right. So when we have a for loop inside another for loop, we're multiplying the amount of times that we do something inside that second for loop, right? So that inner for loop, which is 3, 0, 1, 2, 0, 1, 2, 0, 1, 2, we do that 0, 1, 2 a total of 2 times. 0 and 2, that's 1 because of this I loop at 0. Then 0 and 2 again. 1 I is 1. Does that make sense? Yeah? Awesome. Great. So those are nested for loops. Now, we have 2D lists. Okay? A list of lists. We've had lists before, right? We've had lists many, many times. Oops, there we go. There we go. See my list. We could do 1, 5, 10, 27, 13, yada, 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 right? 4. That's our list. What is this list? Or what does this contain? Ints. Just a bunch of numbers, right? Random numbers. What we can do now is my 2D list, right? My 2D list. What I can do is have a list, and the first thing in my list is going to be another list. And this could be 1, 2, 3. Then I could have another list, and in that list, I could have 2, 3, 4, and then I have another list. 3, 4, 5. A 2D list is just a list of lists, right? So, how many things, how many elements, how many items do I have inside my list?
6.
6 things, right? And solely looking at just the elements, right? How many things do I have in my 2D list?
3 each.
3 each, right? There's 3 each. But you're looking too far in. Yes, there is 3 each in these lists, but how many lists do I have?
3.
A total of 3 lists, right? So, 4, 5, and 6, right? So even though the inner lists within my large list has 4 things each now, at the end of the day, my 2D list still only has 3 things. It has 3 lists. So if we were to print my list, that's supposed to be what number? What happens when we print line 4? What should be the number? Oh wait, whoops. Length. I want to see how many things do I have in my list, and how many things do I want in my to-do list. What's going to get printed when I run this line 4?
6.
6. And what's going to get printed when I run this line right here? 3. 6 and 3. So when we have a 2D list, even though we have a bunch of stuff inside here, like this list in here, it has 4 things. This could have like a million things. And this could be like an empty list even. Let's look at this. I'll remove that. Right, whoop. That's fine. So now this list has 1, 2, 3, 4, 5, 6, 7. There's 7 things inside this first list. There's nothing inside the second list, but that list still exists, right? And now I have 4 things inside this list. What is this going to say now?
Still 3.
Still 3. Because there's still only 3 lists inside of my 2D list. Okay? Does that make sense? 2D list? A list inside of other lists? Okay. Alright, so one of the ways that we have like 2D lists a lot is through the following. I'm going to just copy paste this over. One of the ways that you can do it is like weather data. Okay? We have some weather for the week. We have the city of Chennai. The city of Chennai over in India. India will have 23, 24, 25, 27, and 26. Let's assume that's like Celsius. That's degrees Celsius. Okay? That's going to be that stuff for Chennai. Then, Madison is going to have 0, -1, 1, -3, and -2. Then, San Diego is going to have 9, 10, 11, 12, and 11 degrees Celsius. Just random numbers, right, that we came up with. But W data, what is W data right now? Is it a 1D list or a 2D list?
2D.
2D list, because it's a list of lists. What about cities? Is cities a 1D or a 2D list?
1D.
1D list. It's just a list. One-dimensional list. Now, what's going to happen when we do this? Weather for all 3 cities. How can we get the weather for all 3 cities? How can we print out just all the weather? All of it. The whole list of lists.
W data.
W data, like this. Let's run that. Ooh. Stir and list. Remember, we had the typecast. So making this a stir, string. Run that. Yep, there it is. Weather for all 3 cities. I'll make that a little bit nice and neat. So the weather for all 3 cities is just all the data. Great. Now we can just print it all out. What if we want just the weather for Madison? Print weather for Madison. What should we be putting here now? Remember, Chennai is the first list, Madison is the second list, and San Diego is the third list. What if we just want the weather just for Madison? Yes.
You would type W data, and then like hard brackets, and then 1.
1.
And then you have to typecast to a string.
Yes. Type all that to a string. So what's going to get printed when we do weather for Madison?
So the second list in the middle.
And what are those values?
0, -1, 1.
-3, -2. Run that. There it is. Weather for Madison is 0, -1, 1, -3, -2. Great. What if, and these weathers, like this weather data that we have, it's just like Monday through Friday. Monday, Tuesday, Wednesday, Thursday, Friday. What if I want to print the weather for San Diego on Tuesday? What should we be printing out now? How do we get that? Yep.
Would be W data brackets 2, 1.
Like that?
Oh no, 2 and then another bracket 1.
Like that?
Well, close the brackets for 2.
Close that bracket first,
And then 1.
then 1. Why would that be?
Because you're going, it's 0, 1, 2, which is the San Diego.
Right? So San Diego's here.
And then the index of Tuesday is 1.
0, 1. So what should this be printing out?
Well, you need pass it to a streamer.
Oh, yeah, right. Forgot about that. So what should be printing out when we say weather for San Diego on Tuesday?
10.
10. Let's run that. Great. It's 10, right? And I mean, you caught on to that pretty quickly in terms of bracket, right? That's not super obvious to people, right? But W data is our full 2D list, right? Then, kind of like what Tyler showed us here for weather for Madison, W data at position 1, right? The weather data at position 1 was a list, right? It was Madison, which was the whole list. So, now that you're looking at that list, right, W data at position 1, that is a list, you can then get the position of that list by using brackets again, right? So this 1 is not referring to this 0, -1, 1, -3, -2. No. This 1 right here is referring to this list, W data at position 2, And W data position 2 is 9, 10, 11, 12, and 11. Great. Fantastic. That's exactly how you do that. You get the position first of the list that you want to look at within your list of lists, then the position within that list that you got. Does that make sense? Yeah. Cool. Okay, yeah, and then Chennai's Friday weather. What if I want to add another thing to this list? Let's just hard code it in there. And I'm from El Centro. I'm from El Centro, California. And I just add another list. And let's say, oh, and that's another thing. When we are, sorry, I didn't explain this before. When we are showing our 2D list, we can have it all in one line, like we had before. But what we can also do is have like these, like separated by, just by comma, and then a new line. Okay? So like, here's our opening bracket for W data. Then our other opening bracket for, in this case, Chennai, right? We have all our stuff. We close in our bracket for Chennai. We have our comma. And then you can just do a new line and do more lists like that. And then at the very end, just make sure to close off your W data. Does that make sense? Of how we're doing this 2D list? Because like before we would have it like this, right? We'd have it like that. We'd have it like that. And we'd have it like that. And that also works, right? Having it all in one line. But just to make it look neater, we can also make it look like this. And El Centro is pretty hot. El Centro gets like 40 degrees Celsius, 42 degrees Celsius, 45 degrees Celsius, maybe 44 degrees Celsius, and then one time in my whole life, it got all the way up to 50 degrees Celsius. Just so y'all know, 50 Celsius to Fahrenheit. Oh wait, it's definitely been over 50 degrees Celsius before. I've gone up to, man, I've seen it go up to like 130. 54! There's only one time in my life that I got up to that high. 54 degrees Celsius. Okay, pretty bad. And then let's just say, I'm also from Mexicali, Baja California. It's like a border city. So it's going to have like all of the same values, right? So it's going to have like 40, 42, 45, 44, and 54. What is the weather for El Centro on Friday? How do we get that from W data?
3-4.
3, 4? So how do I write that down here?
It will be W data, brackets, 3, and 4, and the bracket 4.
Like that?
Yeah, and then string.
Oh yeah, string. Whoops. I'm genuinely forgetting that. Just so you all know. Yeah, that was not right. Okay, 54. Awesome. Great. So does that make sense? These 2D lists and how we can interact with these 2D lists? Any questions on that so far? Okay. What will be printed when we do the following? Yeah? What is it?
A.
A. Why is it A?
Because data 1 just prints out the whole list on index 1, which is 40, 50, and 60.
Okay, great.
And then data 1, 2 prints the index of in that list, which would be 60.
60.
And then 3, 3, since there's no list in that index, we'll just give an error.
Yes. There's no data at position 3. Because data is 0, 1, 2, there's no 3. Because of that, it immediately goes into error. Great. It's A. Does that make sense for everyone? Yes, no, yes, no? Great. Now, we typically have nested for loops and 2D lists together because they work really well together, right? What we can do now is we can go into each one of these elements inside of the list of every single one of these lists using a nested for loop. Go in here. All right, so we have all this data, right? Whoops. We have all this data. W data. How can I print out every single number in here as its own number? So what we've done before is like for city data in W data, right? City data is just going to be, what will city data be at the very first thing? Like the very first thing that city data is. What's the first value of city data?
Should I?
Should I?
Oh, no, for city. 23.
It'll be 23.
It'll be the first list.
It'll be the first list.
Oh, this.
Not 23 just yet. We're going to get to that one. But right now, it's going to city data at W data is going to be the entire list of 23, 24, 25, 27, and 26. Okay? It's going to be the whole thing. City data. Let me just break out of that immediately so we can see what's the first thing that gets printed out. We run it. It's the whole list, right? Not the actual value itself. You're getting an entire list. But what can I write now so that I could print out each one of the numbers individually? So instead of the entire list, 23, 24, 25, 27, 26, all as one list object, how can I print out 23 as one object, then 24 as another object, then 25 as another object, then 27 as another object? How can I do that?
A nested for loop.
A nested for loop, right? With our nested for, what should I write for my nested for loop?
For temperature and city data.
Temperature and city data, right? Do we see what's going on here now? For temperature and city data? City data first is going to be a whole list. Then when we loop back, city data will be the next list, then the next list, then the next list, then the next list. What we want to do to get the actual individual numbers, we have to go through each temperature within that city data list. So city data first is 23, 24, 25, 27, 26 as a whole list. But we want to iterate through this list itself. So we do for temperature in that list, city data. Then what do we print out? If we just want to print out all the temperature numbers. Temperature. Right? Let me just break. What's going to get printed out? Oh wait, actually, yeah, that'd be a pretty cool thing. Actually, so first let's see this. What's going to get printed out when I run it like this?
All the numbers.
All the numbers. From 23, 24, 25, 27, 26, and also 0, -1, 1, -3, -2, and so on. Every single one of the numbers as its own number. Okay? Everything. Start at 23, that's our 23. Then 24, all the way to 26, which is here. Then we go to the next number, 0, because it's this number, 0. Do we see how we got there? Iterating through a list of lists first, so we get the whole entire list. Then we iterate within that list that we have for all its values. Okay? That makes sense of why we did that? What's going to happen when I do this? Great. What will get printed out when I put my break here?
23.
23. Is that it? Let's run it. Oh, not just 23. We get 23 and 0 and 9 and 40 and 40. What are these numbers?
All the numbers in the first index.
In the first index, right? Because what's happening here is this. We have our CD data, in this case 23, 24, the list of 23, 24, all of that, the list for Chennai. Then we go for each temperature in the CD data. So we start off with 23, print that out, the first temperature, then we break. When we break, we only ever break out of the immediate for loop, okay? Just the immediate for loop. If this break is inside of a nested for loop, this break is only breaking this for loop, not this for loop. Just whatever for loop it's a part of. In this case, this break is a part of this for loop, right? Because of that, as soon as we break here, we print out the first temperature, 23, break out, we break out of this for loop, but we're still within this other primary for loop, the big one. So we loop back up. So now instead of the list for Chennai, we have the list for Madison. We go in here, and we get the temperature for Madison at the first spot, 0. We print out the 0, then we break. And immediately we break out of just that for loop. What if we wanted to break out the entire thing and only print out 23? Where should I put my break? Or breaks, plural. What we would do is, we would need another break right here. If we were to just print out just the 23, and that's it. And why is that? Why would this only print out 23 and that's it?
Because once it iterates, it breaks within the inner for loop, and then
Yep.
after that, it breaks.
It'll immediately break for the next for loop. Okay? Does that make sense? Breaks are associated within their own for loop. This break is associated with this for loop, and this break is associated with that for loop. Okay? That makes sense? Great. So now, we can print out absolutely everything. The entire thing. Oh boy. Now, oh, actually, let's do it like that. This is also really cool to do with, what is that thing that I taught, I think last week, when you have two different lists, but they're kind of connected with each other?
Parallel list.
Parallel lists, right? We know that at position 0, this is Chennai's data. And at position 0, that's Chennai. Then at position 1 for W data, it's this amount of stuff, and then it's Madison. Okay? So what we can do is this. Instead of city data in W data, we can do city, let's do city index in the range of the length of W data. What will this be giving us now? What is the range of length of W data?
0, 1, 2, 3, 4.
0, 1, 2, 3, 4. Okay? Because the length of W data is 5. 1, 2, 3, 4, 5. Awesome. We have our city index. Using this city index, how can we get, like now I have this city index. What if I still wanted to print out just the temperature for now? Just the temperature. Is this going to work?
No.
No. Why not?
City data doesn't exist.
City data doesn't exist. Right? So let's just update this to the we updated city index. Will this work now?
No.
No. Why not?
Because city index is just a number.
It's just a number. So how can we access these whole lists?
You could do W data and then hard brackets city index.
City index. What should this be printing out now?
I think all of the temperatures.
all the temperatures. Everything. Because this thing that we have written here is the same thing that we had before, but again, now we're just using indices. City index is the range of the length of the W data, all of this. Then for temperature in W data, right, it's the whole to-do list, but now you're only looking for the index itself. So W data at position 3, what will that be?
40, 42.
40, 42, 45, 44, and 54. That list, right? Does that make sense? This is grabbing the whole list. But now with parallel lists, we can do something like this. Jeez. This is a weird way of doing it. I don't know why they would do it that way. Anyways, let's just do it like this. What we can do now is, oh man, okay. Do we want to teach this right now? Okay. This is not going to be like super needed, but print, you could add something called end. And end will just give the print function, what do we want the end to be, right? Usually it's like a new line, right? Anytime you call print, let me just do it like this really fast. When I call print Ismail, then I call print Audria. Are Ismail and Audria on the same line? Yes or no? No. They're in two different lines. But what I can do is with this print, end is equal to a space. Instead of a new line, this will make us both in the same line. It's just going to separate us. Like the end of Ismail is going to have a space and that's it. Not a new line. And it'll be Audria. Okay. I only bring this up because in the following code, in this code right here, what we're doing is this. City is going to the range of the length of the cities, right? So the range of length of cities is still 5, 0, 1, 2, 3, 4, right? Then print city is at position city, and then the end is just going to have a colon. Again, I'm not a super fan of this, but it's just one way of doing it. So this is going to print out the city itself, the city name, right? So it's going to print out Chennai first. Then we're going to go through each day within that data, 23, 24, 25, 27, 26. And then we're going to print out the W data at position city, right, or wherever the city is, and the day of that city's temperature. We're going to print out that number. Then we're going to end it with a space. Okay? So it's going to have it all in one line. And then at the very end, we have print, an empty print. This empty print is just going to be printing a new line. And that's it. So when I run this now, we have the following. Oh, let me scroll up a bit so you can see all of it. So we start off with Chennai, and we print out its data, 23, 24, 25, 27, 26. Then we have Madison, and printing out its data, 0, -1, 1, -3, -2. Does this make sense now of what's going on? Again, I'm not a super fan of doing this, print, and then having the end, changing up the end. You could do it, but just for the sake of showing you how we can use parallel lists with a 2D list and a nested for loop, you could print out stuff like that. Like just printing out all the data itself, organized. Does that make sense? Yes, no, yes, no? Anyone confused by what's going on here? It's okay if you are. This is all new stuff. Yes, no, yes, no? Kind of? Okay. If you need more help, of course, come to office hours. We're more than happy to help you out for like more tutoring on that stuff. Okay. Well, let's continue on. What's going to happen here? Accessing a 2D list using nested for loops, and we have this. What's going to happen when we do that? What will get printed? I'll give you all a minute to think about that. What should get printed out here? Yes.
B.
B. Did you have the same one or a different one?
I have B.
B? Why is it B?
I just kind of like went through it, like when I was 0 and J was 0, I found the data in order.
Okay, great. So when I is 0, J is 0, you get
10.
which number? 10. Then what's the next thing we print?
When I is 0 and J is 1.
I is 0 and J is 1. Okay? So that means J is 1. So it's going to be this list of 30 and 40. Then we still get 0 because I is still 0 and we get 30. 10, then 30. Okay? Let's look at this in Python Tutor just so we can visualize step by step what's going on. Okay. So we have our data. Whoa, that looks funky. But I mean, it makes sense, right? This is what a 2D list is. It's a list of lists. So data is this list of lists, 0 and 1. And list 0, list at position 0 is this list, 10 and 20. And list at position 1 is this list, 30 and 40. Does that make sense? Right, our 2D list. Then, for I in range of length of data, what's the length of data?
2.
2, right? So we got 0 and 1. Then for j in range of length of data at position I, what's the length of the data at position I? I is 0. 2. Okay? It's 2 because we get the length of the data at position I. Data is the list of lists, right? Data at position 0 is this list, 10 and 20. The length of that list, 10 and 20, is 2. Okay? So now, we go in, whoops. So I is 0 and j is 0. So printing out the data at position ji means it's a data at position 0, 0, which is 10. Okay? Print out 10. Then, we loop back up to the j. Now j is 1, and I is still 0. I is still 0. So, print data at position j, right? Position j is this list, 30 and 40. At position 0, 30. Okay? Does that make sense? It prints out 30. Whoops, 30. Then we finish with that for loop. And we go back up to the primary loop for I. I was 0, I is now 1. J in range of length of data at position I, J is back to 0. So print data at position Ji. Data at position J is 0, data at position 0, so it's the first list. At position I, which is 1, it's 20. Okay, next, prints out 20. Then we print out, oh, we loop back up, j is now 1, and I is still 1. So now data position ji is data position 1, 1. So we go to the list at position 1, which is this one, 30, 40. Then the position 1 there, it's 40. Next, it's 40. We finish that loop, we loop back up, but then we're done with that loop too, so we continue on, and we're done. Okay? We can also show it like this. Done with nested loop. So it looks like this. Right? We're at 10, 30, 20. We print out the 40. We're done with the J loop. We're done with the I loop. And we go to the end. Done with nested loop. Does that make sense? Kind of, sort of? So the answer was 10, 30, 20, 40. 10, 30, 20, 40. That's correct. Awesome. We can also do some variable updates. Oh man, I only have 4 minutes left. Jeez, this is so quick. But this is the last big idea that we have for today. We can update the variables using a nested for loop, right? By doing the following. Oh man, this is such a good example too. Okay, let me do this. So we have this, right? Let me remove that, and remove this, and remove this. We just have our nested for loop, and we have our cities. Okay. What if we wanted to get the average temperature for each city, aka each list? What we can do is the following. We can have our total be equal to 0 within our first for loop, right? So we're starting off at 0 each time. Then, within our second for loop, we're going to make total plus equals the day. The day itself, oh sorry, day is the position. So it's going to be W data at city at day, like that. So we get the number itself, right? Because we're looking at indices. Then, when we're outside of the inner for loop, what we can do is print average temperature for cities at position city is, and then we can do our average. We can calculate our average by having our total, right? Average is equal to the total divided by the length of W data at the position city that you're in. Okay? So W data position city is just going to give us the whole list, right? This whole list, this whole list, this whole list. And we're getting the length of that list. So that's our total number of days. And we're using that to divide into total. We calculated our total by going into each one of the individual temperatures within that city data. We update it all. We make our average. Average temperature for cities is stir average. Oh, we need stir over here too. Whoops. Oh wait, do we need stir there? No, we don't. Cities at position city is already a string. Chennai, Madison, San Diego. Okay. So what this will do is it gives us the average temperature for each one of the cities. Let's just look at this in Python Tutor so we can see exactly what we mean. How much time do I have? I have 1 minute left. Okay, so we have our cities and we have our W data, right? We have all of this data, right? It looks a little complicated, but it's just a list of lists, right? Where our first list is 23, 24, 25, 27, 26. Our second list is 0, -1, 1, -3, 2, -2, etc. Okay? Then, for city in the range of length of cities, city starts at 0 because we have a range function, right? Then we have our total. Total is 0. For each day within the list that we're looking at, right, of W data, we're going to add up everything there. So total starts at 0. The very first thing we add to it is going to be W data at position city, which is 0, position day, which is also 0, which is 23. So total is now 23. And then we add 24 to that, 25 to that, 27 to that, and 26 to that. Then we're done with our for loop, our inner for loop. Then we go outside. Then we calculate our average. Our average is going to be whatever our total was. We added up all these things, all these numbers, 125. And we're going to divide that by the length of the data at that city. That city had 1, 2, 3, 4, 5 things. So we're dividing by 5. So the total, 125 divided by 5. Average is 25.0. Then we print out average temperature for Chennai is 25. Then we loop back up. Then we make total 0 again. Why do we make total 0 again? Why?
You're finding like a new average.
You're finding a new average. You don't want to bring in this total of 125 from Chennai over here to Madison. You don't want to do that. You want to reset your total. So you're resetting it to 0. So total is now 0 again. Then your day is 0 and your city is 1. You go to Madison. So now you go to Madison's list and you add up all the things inside that list. And you calculate its own average. That average is -1. Of 0, -1, 1, -3, -2. That's -1, then we print that out. Average temperature for Madison is -1. Does that make sense? Kind of, sort of? I hope that makes sense. We are done now with class. I'm 1 minute over. I'm really sorry about that. But we're still on pace, okay? That's how you do variable updates.